Good morning or afternoon, depending on where you're joining us from. I'm Dane Christensen, the Digital Marketing Manager at GridGain Systems. I want to thank you all for taking the time to join us today for this very informative webinar, how to empower hyperscaling your SaaS infrastructure. Your presenters today are Daniel Gutierrez, a data scientist, author of several books and countless papers on the subject of data science over the last 20 years, and managing editor of Inside Big Data. And Dmitry Satrokhin, one of the founders of GridGain Systems, as well as the chair of the Podling Project Management Committee for the Apache Ignite incubating project. In short, we have two of the foremost authorities on the subject of big data with us today. But before we get into the presentations, I have just a few quick administrative points to make. Daniel and Dmitry will be speaking for about 35 to 40 minutes, after which we'll have about 10 to 15 minutes for Q&A. You'll notice that just above the presentation screen is a questions button. Click there to ask a question at any point during the presentation. We'll respond to your questions during the Q&A segment. Now, we may not have time to get to all the questions during this event, but we'll definitely answer all of them afterwards, so please take advantage of this opportunity to ask questions from these leading experts in the field. You can also use these questions to let us know if you're having any technical difficulties. Also, I wanted to make you aware that we have included the Inside Big Data Guide to hyperscaling your SaaS infrastructure, as well as the PDF of today's presentation in the attachment area. And just one more item, you'll also notice in the ratings button, right next to the attachments button, please do provide us with any feedback you can, and that'll help us to improve our presentation for future presentations. So with that, we're ready to turn the floor over to Daniel Gutierrez. Daniel?
Hey, thanks, Dane. It's great to be on this webinar. Thanks for having me. Today, I'm going to go through a few slides highlighting how in-memory computing can solve many of the critical pain points experienced by software-as-a-service companies, in particular, how to hyperscale your SaaS infrastructure. Okay, let's start by discussing the challenges of SaaS companies in terms of addressing performance and scalability requirements. Due to the SaaS distribution model, the need for scalability and performance is real. SaaS is a software distribution model in which applications are hosted by a vendor or service provider and made available to customers over the internet. Some very compelling SaaS applications are just now hitting the market, all with a common need for a high degree of performance and scalability. In order to be ready for any level of growth, which translates into business success, SaaS systems need to be able to scale. That is, grow capacity on the back end to match customer demand without any major changes to the architecture of the application. So the figure in the slide here shows the traditional architecture where performance and scalability is addressed by adding hardware. Notice how the traditional RDMS server becomes the central bottleneck. Beyond a certain point, scaling the RDMS becomes complex, expensive, and difficult to manage. Even though SaaS companies engaging contemporary technologies to address performance and scalability needs, not were all elastic from day one, running in the Amazon cloud, for example. Many companies built out their own infrastructure, but what's the alternative? Before I get to that, I should mention another important point. When deciding on which contemporary technologies to use to build a hyperscale service, you may need to embrace three types of SaaS businesses and their consumption models: software as a service, platform as a service, infrastructure as a service. So what are the challenges for building a hyperscale service? You should ask the question, do you have the scale and performance needed to make your application a widely successful SaaS offering? Now, depending on how you answer that question, you should consider hyperscale computing, a distributed computing environment in which the volume of data and the demand for certain types of workloads can increase exponentially yet still be accommodated quickly in a cost-effective manner. In-memory computing is a good example of a technology solution designed to help hyperscale your SaaS infrastructure. So in-memory computing is a strategic technology for SaaS. Why is this? It's because the growing demands of big data, SaaS, mobile computing, internet scaling, along with falling RAM prices, have spawned a range of new applications accessing and processing data in memory. In-memory computing is a clear winning technology for SaaS companies because it addresses these needs. So let's quickly consider several potential use cases. Some industries that use in-memory computing to achieve performance and scale orders of magnitude faster than traditional methods are financial services, telecommunications, e-commerce, manufacturing, logistics, among many others. So drilling a bit deeper, let's outline the contributing factors for why in-memory computing appeals to SaaS companies. In-memory computing appeals to SaaS companies due to the level of performance and scale it can deliver. Plus, in-memory computing fits well into a multi-tenant, cloud, and SaaS environment. Plus, with the hybrid SaaS model, providers offer both a hosted SaaS version of their application and an on-premise version. An in-memory computing solution like the GridGain in-memory data fabric can be deployed for either version, and the deployment looks the same. Now let's talk about the benefits to SaaS companies adopting in-memory computing. First, we can consider how companies wish to advance their deployment strategies. Some companies have siloed deployments and separate deployments per customer. One solution toward achieving performance and scale in this case is to use local application level caches, but this strategy is somewhat limiting. Ultimately, SaaS companies really want to add customers on demand and scale out to hundreds or thousands of grid nodes. In-memory computing is the answer to these needs. There's a need to go beyond the box, that is, a server, in order to work on large data sets and perform computations in parallel on a cluster. SaaS companies can break down silos by customer or functionality to have a common platform for everybody and eliminate data redundancy. So using a solution like GridGain's in-memory data fabric with scale-out capabilities enables this kind of growth and provides the ability to address customers easily. Now, there are a number of alternative technologies that can address the needs of a SaaS company. As mentioned earlier, there's application-level caching, but there's also NoSQL solutions and also SQL database, in-memory SQL databases. Other in-memory computing vendors offer point solutions that can be cobbled together, but GridGain offers a single cohesive product with one set of APIs, one set of docs, and one vendor relationship to manage. GridGain offers one integrated solution, allowing the application to pull data in memory for faster access, be able to do compute in a distributed fashion against the data, and do SQL queries across diverse data sets, including structured, semi-structured, and unstructured data. So the graphic on the screen right now shows some important questions surrounding performance and scale for pretty much any SaaS company. First, there's load. How is your application responding to different simulated loads? Stress. How stable is your application beyond the normal conditions? Scalability. How long can your application scale up and scale out in terms of user loads and transactions? Reliability. How long can your application sustain good response levels under expected load conditions? And finally, volume. how is your application responding under different volumes of data? So for my last slide, I'd like to talk about the customer decision points for selecting in-memory computing. First, the reasons for SaaS enablement include increasing the degree of performance and scalability to address the needs of a growing customer base, and also the need to resolve any mission-critical requirements. There are also the needs of specific market segments in the SaaS arena. Now, just a few include software as a service for the financial services industry, software as a service for the transportation industry, and even software as a service for social media ephemeral messaging. But in-memory computing is not just for high-end applications, but also for traditional SaaS vendors in very different verticals who engage in-memory computing and see considerable gains. In the final analysis, when trying to build a SaaS application, in-memory computing is a respected architecture that should be given serious consideration. In the graphic on the slide right now, it's showing compound annual growth rate and rising revenue for cloud infrastructure services, including SaaS. The trend presents an opportunity for in-memory computing to help sustain such continued growth. Okay, that's my piece of the webinar. I'll turn it back to Dane. Thank you very much.
Thanks very much, Daniel. That was excellent. And now let's go ahead and hear from Dimitri, who will approach it from the perspective of the in-memory data fabric that was originally developed by GridGain. Dimitri?
Yes, Dane. Can you hear me?
Yes.
All right, good. All right, hello everyone, and thanks Daniel and for interesting presentation, and thanks Dane. So again, I'm Dimitri. I'm one of the founders at GridGain Systems, and I'm also a chair at Apache Ignite incubating project. So doing a lot of open source. And I'll be talking today about software as a service deployment, but in the context of how you actually solve most of the problems that Daniel was talking about and why you actually need to solve them. So just, and all of that in the context, of course, of Apache Ignite project, which comes with in-memory data fabric, and GridGain, which is a commercial product built on top of Apache Ignite, providing enterprise features on top of Apache Ignite. So let's actually take a look at your application and why would you actually ever want to move into SaaS? And work out on that example why you would need a product like in-memory data fabric. So if you have your application that was designed to support one client at a time, and you were having a separate client installation for every customer you have, right? So if you have 10 customers, you would have 10 separate installations. Now at some point you decide that that becomes just too hard to manage, too hard to maintain all these different installations, and you decide to deploy them into a SaaS fashion on one larger platform, and that platform now has to support all the customers that you have. So obviously, from immediately you start facing issues like performance. Your application was never even designed to support so many customers at a time. All the concurrency issues, all the data transaction issues that how do I maintain transactional semantics of my data? How do I actually continue persisting to the database? Because database doesn't go away. Even though you're deploying to a SaaS environment, your database still stays there. If you were writing data to Oracle, you probably still want to, or to MySQL, you probably still want to continue writing and persisting to Oracle and MySQL. All of that now has to perform a lot faster. All of that now has to scale faster. And that's why a product like in-memory data fabric becomes a strategic option here. Whenever you actually move into clustered environment, SaaS deployment, essentially meaning that you have now many servers supporting supporting your application and client base. You actually will at some point need to stream data into your system. You will need to cache data in memory for performance reasons. You will need to distribute data in memory for performance reasons. So distributed cache as a component becomes very important. You will need to compute on that data. So distributed computations become very important. Distributed map reduce, distributed fork joins, load balancing, fault tolerance. All those aspects become important. You will need to query that data. So maybe use SQL. So a lot of components that you actually will need to have that you didn't have before, that you would need to actually have implemented in your SaaS deployment. And that's why a product like InMemory Data Fabric actually provides it under one set of common APIs. So you can actually view InMemory Data Fabric as a collection of in-memory components, which are independent, but very well integrated with each other. Components like streaming, data grid and distributed caching, clustering and compute, SQL querying capability, et cetera, et cetera. But despite all this rich feature set, InMemory Data Fabric is actually fairly easy to install. It's very simple to use, very easy to install. It comes as one zip file. You simply unzip it, and you're ready to go. The installation is complete. It only adds one dependency to your project. The product is fully Mavenized. If you're familiar with Maven, so it actually can add dependencies a la carte. And one mandatory dependency that you have to have is dependency on Ignite core library, and all other ones if you bring as needed. It's based on standard APIs. If you're familiar with what a hash table is, what a hash map is, what a queue is, what a lock is, all those concepts are now available to you in a distributed in-memory fashion. So Ignite actually, Apache Ignite uses all in-memory standard APIs. All standard APIs, but now in memory and now in distributed fashion. It is also for caching components. It is also JCache compliant. There's a standard called JSR 107, which is JCache. So Apache Ignite is compliant with that standard as well. So APIs are very simple, very natural to get started with it. And most importantly, it runs on a commodity hardware. You can actually deploy it on any kind of Linux boxes. There's no requirements on what kind of hardware you deploy it on. And you can deploy it on as many of them as you like. So the more you add, the more memory you have, the more scalability you have. So let's just take a look briefly at what components InMemory Data Fabric provides. Again, all these components are available for you, but you do not have to use all of them. For example, you can download and use InMemory Data Fabric Apache Ignite, for that matter, just for clustering, or just for compute grid, or just for data grid. And maybe then down the road, you decide that you also need streaming, and you start utilizing streaming as well. Or maybe later you decide you need to use a distributed file system, and you start utilizing that. All those components are available for you, but most importantly, the main value here is that they're very well integrated with each other. For instance, if you're running a computation on the grid, that computation needs to be aware about data locality. Where is the data located that I'm going to be computing on? Where should I go? And which cluster member should I go and start computing on? So all those things come automatic when you use these components within InMemory Data Fabric. So now that we've covered what InMemory Data Fabric is, let's now look again at why we need it for software as a service deployments. Again, just to recap what we were saying, now you had applications that were supporting one client, now they're supporting thousands of clients. You're immediately facing scalability issues, you're immediately facing load issues, you're immediately facing security and data isolation issues. You're now actually deploying in a cloud environment, be that public cloud or a private cloud. Before, you used to deploy probably in a single private server or maybe a mini cluster. Now you have a much larger cluster deployed in some sort of a virtual cloud environment. So your application needs to support all this virtualization that happens underneath. It has to be able to scale elastically on demand. It has to, I mean, you're supporting thousands of clients today. What if you add another 20 tomorrow? how do you actually make sure that your application can cope again? Your application has to be able to scale on demand. You have to be able to add additional capacity to your cluster, be that memory or processing capacity on demand as well. So an application has to continue working without any from a customer standpoint. And of course, it has to be fault-tolerant. Replication and backups within a single cloud deployment or across multiple cloud deployments, which is called data center replication. What if a whole data center now goes down and you still need to make sure your business stays up and business continue to operate? In case of Amazon Cloud, for instance, it would be an Amazon availability zone. So we have many customers deploying in multiple availability zones to ensure redundancy and then replicating across those availability zones. And in that case, if one availability zone on Amazon goes down, you still have others that can cope with the load, cope with the processing. So those are the main benefits of in-memory data fabric. Well, we already touched on performance. We already touched on scalability. Those are important components. Transactions become very important, especially because your database is still there. You're still persisting to your underlying database that you were using before. If you were using Oracle before and you have all this rich database schema, it would be a disaster to move away from that schema into something else. So the best option is to continue using it, but now it has to be used in a more scalable fashion. And you have to be able to combine transactions that happen in memory with the transactions that happen in underlying database. So those are the benefits that you get from an in-memory data grid component, for example, from in-memory data fabric. In-memory data grid is just distributed cache with lots of additional functionality, for instance, like transactions, being able to read through and write through to database, etc. And now also that you have multiple clients that you are supporting. Before you were deployed in an environment where you only had one client per deployment. Now I have 1,000 clients per deployment, or maybe even more, and the number is growing. How do you make sure they don't step on each other? How do you make sure that when you query data from one client, you don't accidentally grab data from another client? Concepts like security, authentication, and authorization become important. Concepts like data isolation, multi-tenancy becomes very important. More of an ability to add and remove clients on demand in a multi-tenant fashion is very important. That's another feature that is available in GridGain as well. So now let's actually briefly take a look at all the components that GridGain and Ignite provide. By the way, Ignite is, again, I want to reiterate, Ignite is an Apache Ignite project, which is it's an incubating project under Apache Software Foundation. And GridGain, and Apache Ignite actually provides all these features that I'm talking about as far as data grid, compute grid, and streaming, and many more. And GridGain provides enterprise-level support and additional functionality like security, additional replication and availability capabilities, etc. So now if we're looking at data grid, it's actually available in both Apache Ignite and GridGain. And from a high-level description, if I had to give a high-level description, you can look at a data grid in a purest form as a distributed hash table, distributed hash map, but in memory. It actually stores data in memory, and it computes, transacts, and queries data in memory. So in this case, a data grid would be a partitioned hash table where every cluster member has a portion of the data. It's almost like sharding, except that in sharding, you usually have to define ranges for keys, and you have to control which shards go where. In data grids, it's actually called partitioning, and in partitioning, all of that happens automatically. GridGain and Ignite will automatically determine where the data should reside, and will automatically partition data for you, and it will be equally balanced. So every node will every cluster member will end up with about the same amount of data as others. So because now you have this partitioning concept, now the more cluster members you add, the more memory you add to your system. So you can easily, within 10 to 20 node cluster, get into terabytes of data scale. You can cache multiple terabytes across 10 nodes, 10 cluster members, or maybe 20, depending on how much RAM you allocate. For large RAM spaces, you can also, for those bit more technical in the audience, Java does not cope well with large memory spaces. So we actually store data outside of Java heap. It's called off-heap storage. And you can actually utilize most of your memory. You can allocate hundreds of gigabytes to GridGain or to Ignite and specify that this memory should go off heap, and Java will not know about it, so you will not get into any performance penalties. But so I already mentioned transactions. So you can transact on that data easily that is stored in memory. You can we support pessimistic and optimistic transactions. Essentially, if you know how to work with database transactions, you know how to work with Ignite or GridGain transactions as well. But one of the distinguishing characteristics of Apache Ignite data grid, in-memory data grid, is its SQL capabilities. You are able to query your data that is cached in memory using ANSI 99 SQL, ANSI 99 compliant SQL. You can put all sorts of SQL keywords into your query. You can do all sorts of aggregations, group bys, betweens, ranges, order bys. You can sort. You can do inner joins, outer joins. You can do unions. You can do nested SQL statements. You can actually nested statements within each other and join on them as well. So there's absolutely no limitation to what kind of SQL you want to run on top of Ignite. But the advantage here is now that this SQL is processed in parallel and executes in parallel. So it completes on the larger data sets, it completes a lot faster. So you get performance advantages. And indexes are also all in memory. So the index lookups are very, very fast. But as far as other advantages that come from data grid is its integration with compute grid. If you think about it, there are several ways that you can interact with your data. One way is using standard key value API. So that's what a data grid in the purest form was, right? It's a standard key value data store where you can access data by key. But on top of that, Apache Ignite added additional way to interface with your data, which is SQL. So you can actually use SQL now as a language for interacting with your data. And Compute Grid actually offers a third way to interact with your data, which is with fork join or map reduce type of computations. So that's yet another API, another window of how you can look into your data and how you can compute on your data. So those are directly supported features of in-memory Compute Grid, which is MapReduce. There is support for MapReduce, but we're noticing that MapReduce, in a lot of cases, is an overkill for in-memory computations. It just was never meant for it. It was meant for Hadoop-like batch-oriented computations that can run for hours. In memory, when you run stuff in memory, you usually look at seconds and below. So MapReduce is usually considered an overkill, and lots of our customers use our fork join capability, which is a special case of MapReduce, which splits your computation into multiple pieces, runs it in parallel, and simply aggregates it together. It's a special case of MapReduce, but it performs a lot faster for your usually when you're doing in-memory computations. So those two APIs are available for you in Compute Grid. Of course, on top of that, it also supports automatically load balances the computations within the grid, automatically provides fault tolerance, prioritize job scheduling, job prioritization. You can have assign different priorities to your job. You can even checkpoint long-running jobs, so whenever a crash happens, you don't have to restart from scratch. You can even have a situation when at some point your grid gets unequally loaded, and for that, Ignite has a feature called job stealing or work stealing, where a less loaded cluster member would go and still work from a more loaded cluster member. So it's a fairly feature-rich, fairly feature-complete Compute Grid. And again, the integration with data grid matters a lot because whenever you're doing distributed computations, the last thing you want is for the data to travel around. You want to know exactly on which cluster member the data is stored, so you can actually send your computation to that cluster member. And when working within Ignite, since these components are both provided within one project, integration for us is very easy, and we will automatically take care of that for you. So data locality issues are automatically taken care of. And last but not least components that I'll be talking about today is streaming. And when we look at streaming, there are two main use cases. Actually, even the slide title says streaming and CEP. There is a streaming data, or ingesting data into your system and processing it in multiple stages. For example, stage one, that's first level of processing that it produces some data that will have to be processed by stage two. So this kind of streaming workflow supported by products like Apache Storm. So that's one use case that you can think about streaming. Another very important use case is complex event processing, CEP. What it means is support for sliding windows. Streaming data never ends. It keeps on coming. And whenever you have so much data, and it's been coming probably for the past 6 months, you rarely want to query all the data to the beginning of time. You usually want to query a window of data, a sliding window of that data, like last week, maybe last hour, maybe a third week of last month. So you want to define those windows, you want to query those windows. And that's another feature that is very important for streaming, so it's complex event processing. Ability to query into sliding windows of data. And those two actually use cases are supported within Apache Ignite. You can easily ingest data from Apache Ignite. It's actually an open source project, and we're getting a lot of outside contributions in integrating with products like Kafka, like Storm, Akka. All those integrations make it easy to storm data into Apache Ignite from different systems. And then you can actually query this data inside of once it actually has been ingested using our standard SQL capabilities. So our complex event processing is supported using standard ANSI 99 compliant SQL. You can query into any window. You can query, again, you can use all sorts of aggregations, all sorts of inner joins, outer joins, nested SQLs. All the SQL is available to you when you're querying into those sliding windows. So those use cases are covered by streaming. I also want to briefly mention some of the enterprise features that provided by GridGain that are not available in Apache Ignite. One of them is our feature-rich monitoring and management for DevOps. So GridGain provides fairly feature-rich management and monitoring capabilities that are both can be used from a GUI console or from a command line console. Of course, GUI console has a lot more features, and you can actually check application live status in how many nodes you have. You can search through distributed logs. You can take distributed thread dumps. You can actually take all sorts of debugging searches you can do within your Visor console. And lastly, I want to mention the difference in feature set between Apache Ignite and GridGain. So Apache Ignite is a fairly feature-rich product. It supports all the data grid, compute grid, streaming. There's also service grid, messaging, file system, distributed file system. All this functionality with all its features are available in Apache Ignite. And you can think of GridGain as a layer on top of Apache Ignite that provides enterprise-grade features. Such as first security, multi-tenancy, features that are important for SaaS deployments. Features like data center replication, replicating across multiple data centers. Features like network segmentation handling, local recoverable storages, rolling upgrades. Most of the features that you will find in GridGain will have to do with making sure that you never have to restart your cluster. Your cluster stays up regardless of your data schema changes, of your GridGain version changes, of your own version changes. You can upgrade your own data, your own application without restarting your cluster. You can upgrade GridGain application without restarting your cluster. You can replicate with data center replication and security. All of that is available in Enterprise Edition. And of course, it comes with enterprise level support and maintenance and patches. So with that, I'll hand it over back to Dane. And if we have any additional questions, I'll be happy to answer.
Well, super. Thanks, Dmitry. That was great. Now, I know that Daniel had some questions for Dimitri, kind of from the an analyst perspective to someone like Dimitri, who's deep into this technology. Daniel, did you want to go ahead and pose? I think we've got time for a couple of those questions.
Yeah, sure, Dane. I definitely have a couple of questions for Dimitri. Let's start with this one. What's the advantage of a single in-memory solution versus a number of point solutions to solve the needs of SaaS applications?
Well, so the question is, why do I actually even need to move in SaaS? I mean, why wouldn't I just continue to deploy individual applications, point solutions, and not have one in-memory platform? So the main advantage again is manageability, or you get one platform which you can manage as one, you can deploy and scale as one. So from a management and scalability perspective, it becomes very easy. And on top of that, you actually can utilize your resources a lot better, because when you deploy in one in-memory platform, what if some of the portion of the application now underutilizes some service and another is becoming overutilized? All of that will be also automatically managed, on top of all the features that I already listed, such as transactions and queuing capability as well.
Okay, that's great. Here's another question. What verticals in the SaaS space do you see demonstrate performance improvements with Data Fabric?
Right, that's actually a good question. Predominantly anywhere where you need scale and performance would be a good application for an in-memory data fabric. That's why software as a service deployments become a very good candidate into that. In this area, we actually see a lot of financial firms that need to do a lot of that require a real fast performance and really low latencies, and a lot of times they even are very, very concerned about jitter. Even though your performance may be okay, but the jitter, the percentiles of that performance may not be great. So even that becomes important in financial industry. We see a lot of application in logistics, being able to handle multiple clients at the same time as well, and moving into SaaS. We see a lot of applications in e-commerce space as well. And there's also, of course, applications in bioinformatics, medicine, drug companies, and gaming, and many others.
Oh, wow, that's incredibly broad. Here's one more question that I think applies to all the listeners today. How easy is it to deploy and operate an in-memory data fabric in a SaaS environment? Well,
it's actually a very good question as well, because whenever you move into deployment from a single point deployment to a cloud-based deployment, there are a lot of things you have to consider. For example, even from a networking standpoint, I mean, different clouds support different infrastructure. There's a multicast layer may be enabled, then TCP/IP addresses may or may not be changing. For example, on Amazon AWS, TCP/IP addresses constantly change, or multicast is not even there. So how do you easily deploy in that environment? It's important that the system is pluggable and adaptable. So Apache Ignite has actually two sets of APIs. One is public API, but another is this SPI layer, server provider layer, interface layer, which actually is used to adapt into different environments. And clustering and deployment is one of those SPIs. So we have we have discovery and clustering protocol that can work over. We have a plugin that can work over multicast, over TCP, over Amazon S3 store. We have a plugin that works over a database, a JDBC based plugin. We have a plugin that works over distributed file system. So with this kind of set of plugins, we're able to adapt pretty much into any environment out there. So from a pluggability, from a cloud-based support, it's important that product is pluggable in that sense, and can adapt to whatever environment your cloud imposes on you. From a management standpoint, it's important that there's also You can also manage it from one place. You can also deploy onto that cloud from one place. You can search through the logs from one place. So that also becomes important. And those are the features available in the Fabric.
Okay, that's great detail, Dmitry. That's it from me. I'll send it back to Dane.
Yeah. Thanks, Daniel. And great questions, great answers. And we do have quite a few questions from the audience as well. So let's go ahead and dive into some of those. And looking at the questions, they probably look like they're all probably best for Dmitry, but by all means, Daniel, if you have some thoughts on any of these questions, feel free to weigh in there. But let me start with this first one. And it's about GridGain, so this will be for Dmitry. The question is, will GridGain continue to release a free open source distribution with GridGain branding, or does the Ignite project supplant this?
Well, that's a very good question, and that's always a topic at GridGain as well. We definitely are focusing on Apache Ignite. So Apache Ignite is going to be the product, the backbone for all the products that are provided by GridGain. So, in short answer, in the current form, Apache Ignite 1.0 essentially replaces GridGain Open Source Edition for future deployments. Having said that, GridGain is going to have a community edition, which is also going to be open source and also based on Apache Ignite, but it will just be a little more, it will have a little more updates. I mean, there's more bug fixes, it may have some additional features that have not yet been able to make it into Apache release. So from that standpoint, the GridGain is going to have community edition, but it will also be heavily based on Apache Ignite as well. And of course, Enterprise Edition is going to be based on GridGain Community Edition.
Okay, super. Thanks. And here's another one for you. Again, fairly technical. Is there a way to use SQL to reference different parts of a composite complex key type? Or are the query fields restricted to the value types in the cache?
So the question is, how complex can you get on indexing and on SQL queries, and can you actually look into a complex key type? And the answer is yes. You can query quite complex. You can create quite complex keys. You can create group indexes. Also, you can actually index based on multiple fields, not just one field, or you can actually index on any field within your key. So both primary indexes and secondary indexes are supported. And the majority of use cases, of course, come around secondary indexes, all these where clauses, joins, et cetera, et cetera. So the answer is yes.
Okay, super. And again, here's another technical question, a number of technical questions. Looks like we've got some other kind of higher level questions to come too. But here's this one. Is it possible or planned to modify cache data using SQL?
So the question is, can I write to the in-memory data versus just use it for queries? Currently, you can update data in cache using our key value API or our compute APIs. And ability to write into in-memory data using standard SQL will come end of Q2 most likely. You can actually start playing with it. But right now, there is no such ability. You still have to write using key value API, doing standard pulls or loads from database. But you can still query it using complete SQL, ANSI 99 compliant SQL.
All right, great. Here's another one. How easy or difficult is it to implement Apache Ignite on AWS or Apache Web Services?
Well, I think I already kind of answered it when Daniel asked it. It's actually it has to do a lot with your system being able to adapt into multiple environments. For AWS, we have a special S3-based plugin, which automatically discovers node based on S3 buckets. Every time a node comes up, a cluster member comes up, it will write its coordinates into an S3 bucket, and other nodes will be able to read it, and that's how discovery happens. Once discovery happens, Ignite cluster is able to author it. So once the nodes actually find each other, the rest becomes easy. So from that standpoint, we have a special S3-based plugin that you can utilize for that.
Okay, great. Now, here's another question. What are the hardware/software requirements or dependencies a SaaS needs to run Apache Ignite? And by the way, if there's a difference between Apache Ignite and GridGain on that, you probably just expand on that too. But
well, I mean, to answer that, there's no difference in either one. Neither Apache Ignite nor GridGain actually imposes any requirements upon hardware. We deploy anywhere where you can run Java, .NET, or C++, we can be deployed in. So from that standpoint, I'm not aware of any limitations. The limitations are usually imposed by the user application. For instance, if your server can hold only 100 gigabytes of RAM, you obviously, and you have 10 servers, then the maximum amount of data you will be able to cache is a terabyte. So that's a limitation imposed by the customer infrastructure, but not by Ignite or GridGain for that matter. So essentially, you can, as much memory you give to Ignite and GridGain will utilize as many processors and as much memory as you can provide.
Okay, great. Okay, and here's another one. Will the class and package names be different between Ignite and the Enterprise Edition? And this would, a comment, this would make it harder to migrate from open source to enterprise.
The answer is no. They are right now. As of today, they are, but next week they will not be anymore. We're releasing GridGain 7.0, which is fully based on Apache Ignite. And all the package names will be absolutely identical. As a matter of fact, the GridGain 7.0 will be based on Apache Ignite, so the difference in package names would be impossible there.
Okay, great. Let's see what's next. What support levels does GridGain provide with the product? And assuming that that's referring to GridGain Enterprise, but you might want to also talk about Apache Ignite in that respect.
Yeah, I'll talk actually about both. On Apache Ignite, it's an open source Apache project. It's just like Cassandra, just like Hadoop, like any of those projects. It's an open source project with a growing community. We have very active dev lists. You can subscribe and actually become part of the community. There is a community page on Apache Ignite website which talks about how you can contribute there as well. So there's a lot of tickets, Jira tickets that you can get involved in, but that's a little bit of a digression. So as far as support goes, there is a Ask a Question section on Apache Ignite website where you can easily go and ask a question, and someone within the community will answer. We're usually very good about that. From a GridGain standpoint, we provide enterprise. GridGain would provide enterprise level support. So that would include predefined SLAs, predefined response time, 24/7 support capabilities, maintenance and patches that can be provided overnight. All that enterprise level support, of course, will be provided from GridGain as a commercial entity.
Okay. Thank you for that answer. And here's one more question. How long does a typical implementation take for a SaaS platform?
Well, I mean, it depends on the project. So it's generally speaking, the way you can interface with the system matters. So, for instance, in Ignite, you can interface with Ignite in key value fashion, in SQL fashion, in MapReduce and fork join fashion. So generally, one of those paradigms will apply to your application. A lot of times we've seen that SQL significantly minimizes integration paths. So it's a matter of being able to reuse the same queries that you use in database to reuse them in memory. And Apache Ignite actually, you can literally take your Oracle query or MySQL query and with very minimal changes run it on top of Apache Ignite. So Apache Ignite generally supports it. And also integration with underlying databases matter. So being able to read data automatically from database and write data to the database automatically matters. So Ignite has a plug and play integration with any type of RDBMS out there. Oracle, MySQL, Postgres, et cetera, et cetera. So with those type of integrations, I would say they minimize the integration time. There's, of course, some time that would have to be consumed by adapting your code to work with these APIs, to work with this SQL, work with your database differently. But those kind of capabilities significantly minimize integration time.
Okay, great. Great answer. And now we did promise that this would be a 50-minute webinar, and we're pretty much up against that now. So if we didn't get to your questions, then we will definitely follow up with you after the event. I did want to first thank Daniel and Dmitry for your excellent insights on this subject, and also to remind all the attendees that we do have these attachments. We've got the Inside Big Data Guide to Hyperscaling Your SaaS Infrastructure available in the attachment section, as well as the PDF of today's presentation. Also, definitely would appreciate you giving us any ratings that you can to help us improve future presentations. And with that, I want to thank all of you for attending today's webinar, and hope for you a great rest of the day.
Thanks, everyone.